It's my belief that in order to understand Bayesian statistics, it's necessary to understand Bayes' theorem. And understand Bayes' theorem, it's necessary to understand joint, marginal, and conditional probabilities. So in this video, we're going to look at joint and marginal probabilities. In the next video, we're going to look at conditional probabilities. And we're going to do this by example. And the example is going to be that we've got a bunch of counts. And these counts are trees that are cross-categorized according to species and according to height class. So in terms of species, we've got 3 species: aspen, spruce, and pine. And in terms of height class, we've got 2 height classes, short and tall. We have 1,000 trees, and they're cross-categorized like that. So we get 1,000 trees. If I divide each one of these numbers by 1,000, then what we arrive at are probabilities. Because you think about the frequentist concept of probability, it's the long-run relative frequency. So for example, if I've got this value 0.15 associated with tall spruce trees, that would be the probability that a randomly selected tree from this population would be a spruce tree that was tall. So let's begin with this idea of joint probabilities. I'm going to start off with joint. And where are these joint probabilities found in this table? They're found in the body. So the joint probabilities are found in the body. The key word is and. So we think of a specific example. That might be the probability that a randomly selected tree is spruce, tall. And what that means is that a randomly selected tree from this population would simultaneously, that's where this word and comes in, would simultaneously be a spruce tree and a tall tree, and that is 0.15. In terms of the symbol in this designation, the symbol is this comma. In terms of calculation, there actually is none. There's no calculation required because the joint probabilities are obtained directly from the body of the table. In terms of general examples, we would represent the joint probability as the probability of the species, comma, standing for and the height class H. So that would be joint probabilities. Now let's think about marginal probabilities. So now let's do marginal. So where are the marginal probabilities found? Not surprisingly, they're found in the margins. So if you think about the marginal probability of species, they're shown here. In terms of the marginal probabilities of height classes, they're shown here. So they're found in the margins. The key word would be the word overall. So if we think about this value of 0.55, that's the overall probability that a tree randomly selected from the population would be short. This value of 0.45 is the probability that a randomly selected tree from the population would be spruce. If we think about a specific example, let's think about the probability of a randomly selected tree being pine. You could represent it that way. In terms of the symbol, there is none. We just represent it like this. In terms of the calculation, well, how do we obtain the probability that a randomly selected tree would be pine? How do we get this value of 0.15? Well, we take the joint probability of pine and short and add it to the joint probability of pine and tall, and that gives us our answer. So in terms of notation, what we're doing is we're taking the probability the tree is pine and in some height class and summing it up over all the different height classes. So let's do another example. What's the marginal probability that a tree would be tall? How do we get that? we start off with joint probability that it's in some species, and then that it's also tall, and then we sum up overall the different species. So the marginal probabilities are obtained by calculation. In terms of general examples, we represent the probability of it being in a particular species as PS, being in a particular height class, PH. So let's just do a comparison between joint and marginal probabilities according to their features. Where are they found? Again, the joint probabilities are found in the body of the table. The marginal probabilities are found in the margins. The keyword is and. This is the probability that a tree randomly chosen is simultaneously spruce and tall. Here it's overall. This is the overall probability that a randomly selected tree would being a pine. There's the designation in terms of symbol, comma. There's the comma right there. There's no particular symbol here. In terms of calculation, the joint probabilities are really, in a sense, foundational. And what I mean by that is that once we've got these joint probabilities, we can go from the joint to the marginal. However, we cannot, without some assumptions, go in the opposite direction. So the basic stuff is the joint, and then from that you can calculate the marginal, or we'll see in the next video, you can calculate the conditional probabilities, and these are the general ways we designate those shown here.